Hi, welcome to another Great Cow Basic training session. Okay, so let's just get into this as fast as we can. So we've covered so far making some LEDs work on that little old board. We made them flash, then we made them turn on and off. And yesterday we went through software pulse width modulation, and we've been using pulse width modulation for a static frequency using the CCP module. Okay, so today we're going to be using the same module, but we're going to use it across multiple channels. I'll explain that in a moment. And then we're going to use, in the same microcontroller, a hardware module called PWM. And you might need to do that because you might want to use the CCP compare module for another task. So they've given you a dedicated pulse width modulation. And to be quite frank, the CCP version of pulse width modulation module is very old. It's been there for a long time. And generally most computers, microcontrollers have that. Tomorrow we'll be going back to LEDs and we'll do some rotation stuff and just widen the language skill set. We have a PIC, an 16F 18313 connect to a PIC kit 2. Okay, so what we're going to be doing is using that PDIP controller, and we've got LEDs and things. We've now got things connected to the chip with these on these 8 legs. Okay. Now we're going to be generating signals that look like this, and for those who looked at the previous video, we have an oscilloscope. Okay, so let's look at that oscilloscope now. Here it is. This is the oscilloscope. It's hooked up to one of the LEDs, and you can see there are 4 LEDs flashing, but that's where we left it after the previous training session. So I'm going to quickly hook up for this session another part of the scope. This is a dual channel scope, so I can quickly insert another little wire into here, and if I push it into just below the previous one, I can then pick up the second channel. Now I've got some software, remote software, it's not remote software, it's on my PC, that actually controls this so that we don't have to fiddle with the menus. Okay, all right, let's just push those LEDs apart. Okay, so we're going to be controlling the top 2 LEDs, the green one and the yellow one, and we're going to come back to that in a moment. Okay, let me just power up the software. This software is from a company called Gabtronics, and that Gabtronics software looks like this over in my UI, and it sort of turns on and off that oscilloscope. So I'm just going to press the auto button here, and it should pick up two signals, which it has, which is fantastic, and it's turning on and off, and that's where we left it last time. Okay, let me just do it again. I'll auto that again. That's better. So we've got 2 signals, and those signals are, if I just recap where we got to last time, we'll look at that. It's actually operating at 38 kilohertz. If you remember last time, is it kilohertz? Yes, it's hertz. Kilohertz, yes, 38 kilohertz, and both are on the same. So we set it up yesterday to be like that. So if we go back to PowerPoint for a moment, okay, we'll just walk through what we're going to be talking about and what we're going to be doing. So this is a recap of what we did before. We're using this mock-up of a microchip low pin count board, and we've got 4 LEDs hooked up to it. Last time I said we use software, pulse width modulation. I'll just turn my pen on here. My highlight. We did this last time, software, and that only works when it's operational. And then we use this one, which we're very clear. I forgot to mention, this only works on CCP1 channel 1 PNW. Okay, so it only works on one channel, and it was the original one that Hugh wrote when he first wrote the software. So we're going to cover that. So most chips now have more than one CCP channel. They have up to 9, so we have up to 9 now, and those 9 are documented in the chip architecture. Okay, we've only got 2. Okay, we've got CCP1 and CCP2, but some have got a lot more. The difference that we've got here is that we've connected the LEDs in. So we're going to be using a thing called PPS. This is a PPS chip. Okay, this PPS chip means that I have to connect the CCP module to the actual output. So I'm going to connect, if you look at this here, this LED this is one channel here, and this is going to be another. This is the second, this is CCP 1 and 2. And I need to do that in software via the PPS. So we're going to have a look at PPS. And we're going to return back to this diagram in a short while because we just need to make it work for us, okay? Now, let's just look at how we're going to do this, okay? So what's important, we need to set, it says 3 things, but in reality, let me just make it very clear, that's 4 things, okay? That number, I'm so sorry, that is actually 4 things, okay? You need to set 4 things. You need to set a timer frequency, okay? So you need to do a timer frequency, and that is a constant that we need to set, and it's a value, okay? So we say hash define pulse width modulation timer 2 with a frequency, and we just tell it a frequency number, like number 8, 38, whatever number we want. It's a frequency, and that frequency is against a timer, and we've only got 1 timer available on this chip, so we can only use number 2 for this type of capability. Then we need to tell it the duty cycle. So we say what that duty cycle is, and is another constant. Define a constant with, what is key here, we're talking to the channel here. So we're saying PWM YY, and that's the channel number. That can be 1 through to 9, and then a duty, a number. Okay, I'm going to show you an example in a moment. And then we need to tell it a clock source. So we need to join. If you can think about it as doing a join, we need to say for which PNW what that clock source is. So we're saying here that the ZZ, okay, is our channel, and it's the clock source is number something. Now it's be number 2 in this case, and we're going to be looking at that in detail. So we're saying the clock source for a particular channel, which is either number 1 or 2 on ours, is a clock source of 2, and it's hard coded on this one, but on some chips you can choose channel 2, 4, 6 or 8, okay? And then to use it, we're just going to say pulse width modulation on open brackets and the channel number. It's really simple. So here's an example. So you don't need to define all the channels or anything, just the constants that you need, okay? So the minimum is a timer with a frequency, a channel, and with a duty. Okay, so this is an example of the minimum that you need to set to make it work. So we're going to say define here, define the channel 2, the timer 2 with a frequency of 38. Then we're going to define on pulse width on PNW channel 1, the duty is 50 and with a clock source of 2. Okay, now why is that important? Because if you had another clock source, you'd have to specify it, and then we're going to turn it on. Now, just to prove to you this all works, we're gonna go back to our editor here, and then we're going to go into SynWrite into the IDE. We're going to have a little play with what we're doing. So this is the code from yesterday. It's actually working in that scope as we can see today. Okay. Now I am just going to take what do I need? I'm going to take the chip statement. And I'm going to take the constants for the hardware. That's like the LED part that we needed from yesterday. Okay, so that's the only 2 bits I'm going to take across. Okay, all right, great. Then I'm going to save that as training 6A. Okay, now great. So the first thing we need to do is do the PPS. Okay, we need to do the PPS. If we don't do the PPS, we won't have connected the channels. Okay, all right. Click on the PPS icon. There is another way you can do IDE tools, and you'll see it in there as well. So it's just loading up the PPS tool for us. Here we go. Here's my chip, and if you remember from yesterday, we're going to be using CCP1, and that's going to be on RA1, same as yesterday. And today we're going to be putting CCP2, because we can use 2 of them, on RA2. And that's as simple as that. But what we've done is, if you see the green here, we've connected the CCP1 to RA1 and CCP2 to RA2. Copy that. I'm going to paste it into our program. Great. So what we've done, we've taken the chip, defined the chip, defined the PPS, and we've said it that the ports are all defined as constants. Let's just go back into PowerPoint for a second, and I'm just going to take you in, and we had this piece of code here. Let me just take a copy of that, right? Okay, make it really simple and fast. Okay. Back. You can't see what I'm seeing, so we'll just do that all again. What I said is I've got the chip define, PPS, and then we've got the same constants we had from the previous session, which is just a set of constants to define the LEDs. Finally, I went into PowerPoint and quickly grabbed the code that was in that example, okay? And I'm just going to paste it into there. Oh, it's not indented, okay? Now, if I put a do loop, oh, do I need a do loop at the end of it? I should. I'm just going to do that for good practice, right? Okay, all right, just to show you for good practice. So I've said time of tooth, frequency of 38. Let's just make it 8 for our scope. Duty cycle of 50 with a clock source of 2. I can only choose clock source 2 in this particular chip. I'm going to program it and then go to the lab view on this and see if we've actually done it. Well, I can already see in the lab view that we've actually done something spectacular. Here we go. Let me just go back into the Gabtronic software, and I'm just going to pull it onto the oscilloscope so you can see it. And there we've got a scope. We've actually got a signal. Now, we're getting a signal on the second one. Not quite sure why. I think it's a. Oh no, I've turned it on. Let me just auto that for us. And then we've got a better. It's now got locked signal on there, and I'll just make it a different scale. Look, we've got the same signal on those channels because we have. Now, let me just show you what we're going to do in SynWrite. So we can generate really simple stuff here. So duty cycle 2, I'm going to put into here. It's the same sort of syntax. PWM 2, clock source is 2. And let me just paste that into there. Look. PWM 2, because we've got 2 channels on here, and I'm going to set the duty cycle to 25. I've already set the frequency to 8, so we should see some action in the lab here. But we haven't. I've done something wrong. It's either a typo. What have I done wrong? Oh, I can see what I've done wrong. I've connected the oscilloscope up incorrectly. I put it on the wrong pin. Isn't that wonderful? Let's just, that's very good actually. Let me just get my white back. There we go. That is now fixed, and we know from our source code that we're not doing anything. It's constantly on, so I can change the frequencies in here. I can change the overall frequency of both because this is related to timer 2. Okay, I can then change a duty. I can play with the duty, see, because the duty is the constraint. So I'm constrained by the frequency, but the duty I can play with. So I can have different duties on different channels. And what is very clever, okay, and that just goes to prove it, look, okay. Now, I do apologize about my little oscilloscope here. Let's just make that a bit better for you to look at. There we go. You can see that's somewhere about right. Now it's a bit of a dirty signal, okay, but it's working. And what's key about this is I can now do that across 9 channels if I had a much larger chip. Now, That's the CCP module. But there's also included inside of here another module called the PWM module. Very, very similar setup for fixed mode. Now, what's different about the fixed mode is, remember, in the source code, it's constants, and I can't change constants as I'm running. Later on, we will be looking at how you actually make them change tomorrow. So these are constants, and they're very, very low. It's 106 words, very small amount of memory to get this operational, which is the beauty. So let's just save this program as 6, okay, as 6B, and then we're going to change it to the other channels, okay. I'm just going to knock all this code out because we don't need it. Well, we can leave it. Actually, we can leave it in. All right, we're going to leave it in. But the first thing we're going to have to do is change the module. And as I said in PowerPoint previously, the key thing in here is we need to set up that module. Okay, let me just change the page here. Okay, and on the PowerPoint because we need to go back. We're now going to look at fixed mode. Okay, and this is using the PWM module. It could be module 1 to 9, but we've only got modules 5 and 6. Now, these modules are a little bit confusing. How do you know what's inside of a chip? Well, you can wade through the data sheet, but with Great Cow Basic, we have a little trick for you, okay? So this little trick is a tool. So if I open it, if I install, and I'll show you how to do this later on, I'm going to install a tool called Pick Info. And Pick Info, if I, can I zoom in on my desktop? Let me just zoom in on that if I can. Let me just have a look, see if I can zoom in on that for you. One moment, okay. I don't think I can in reality. No, I can't. I'm going to type in here 16F18313, enter, and it gives me the options for this particular chip. Okay, all right. Now, what's beauty about this particular application is I can actually come into the data. I can look at the bits, and I can do searching in here. So let me look at the bits, and I'm going to type in CCP. And look, CCP is here. It says there's CCP1. And if you look at it carefully, there's CCP2, but there's no CCP3. So look, if I type in 2, it takes me to it. 3, I get a bing in my ear, nothing. Let's do the same for pulse width modulate. Oh look, 5. Look, it found a 5. It found a 6. Doesn't find a 7. If you look at another chip, we will look at another chip, and let me think of a really big chip, okay? Let's look at the 6. No, that's a pretty constrained one as well. 16F47Q10. Here we go, Q10. Select it, bits. Let's type in PWM here. Well, we've got a 3, and we got a 4. I'm surprised we don't have more, but some of them have up to 9, so you've got to sort of pick your piece. So this is showing you how you can determine what your chip capability has. So 16F18313, select it, click, do a search on the bits, and then just type in pulse width modulation. Oh, I'm so sorry, pulse width modulation, and it says I've got 5 and 6. So this definitely has 5 and 6. Okay. So what I'm going to do is I'm going to go back into Synwrite, I'm going to do some editing, and we're going to take out the PPS section of the code here because we need to restart our code in this demonstration. I'm going to add in a new PPS piece, all right, and that PPS piece is going to be all focused on using the pulse width modulation. All right, we're at 19 minutes, and that's horrendous. But never mind, keep going. PWM 5, I'm going to attach that to number 1, RA1, PWM 6 to RA2. Copy that out and paste it into my program. Down here, I've got the same constants, but now these PWM numbers here are different. I have to put 5 in here and 5. I'm going to change that to 6 and 6, and we've got the same outputs. But remember, this is a completely different module, okay? And because it's a different module, I have to tell it it's actually the pulse width modulation module. I have to tell it that it's this particular module, okay? The other one assumed CCP, okay? Module, is that correct? Oh, it's gone blue, look. It's gone blue because it's valid, okay? There we go, great. Let's compile that up and see what happens. And I'll just show you a sin right because I didn't do any of it. I pasted the PPS into here, and all I've done is edited the values in here. I've just changed that number to a 5. That was a 1 before. Changed that to a 5. That was a 1. This was a 2. This was a 2. And I've just added in the comma PWM module. Fantastic. We've changed the complete architecture. We are using a different channel, different type of architecture here we're using these modules. So we've got plenty of ways to set up pulse width modulation in Great Cow Basic. You know, we can use software, hardware, CCP, and hardware PWM. Okay, very simple to use. So with that, I'm going to call it a bit of a wrap because this one's gone on a bit, okay?